We have already used the rules of logarithms to combine logarithms from many different terms into one logarithm. Now we are going to see the opposite process. We have one logarithm, as you can see right here, and what we want is use the rules of logarithms in order to change it into an expanded form, meaning in order to rewrite this as a sum and a difference of logarithms. What I have are three different arguments, three different variables here, the product of x, y, and z. What I can do is I can apply the first rule right here, the product rule, in order to split this logarithm. I can do it in two steps if you want, just to make sure that you're not confused. But since you have a product that is applied twice, x times y times z, you can do it in one step as well. So basically, what you have is log of x plus log of y plus log of z. Okay, now if you want to see how the product rule is applied, because the product rule has only the sum of two logarithms right here, and I end up with the sum of three logarithms, you can do that into two different steps. So you can assume that you have the log of xyz, but you can assume that is xy times z. Okay, let's split it. So I have this product, but I consider it as one entity. If I apply the product rule right here, what I'm going to get is log of xy plus log of z. So in this way, I just separated the z, the log of z, from the rest. Now I can reapply the product rule right here, because I have x times y inside my logarithm, and I can rewrite it as log of x plus log of y. And this is added to the log of z. Since there is no priority here on my operations, the whole thing is nothing else than log of x plus log of y plus log of z. Now, one thing that I want you to see and be very careful is that every time that you split the logarithm right here, you assume the base of the initial logarithm. Now, since the base is missing, I assume that this number is 10. So as you can see, I keep it right here, or as you cannot see, because I'm using the log of 10. So by what I'm saying is that if this was the log with base 2, then the result would have a 2 in all logarithms. So the final result for my expansion is going to be a sum of logarithms with base 2, if the initial one had 2 as a base, and this will be the final answer.